Well, I think we should go ahead and get started. Welcome, everybody. This is Alistair Jackson with O'Brien and Company, welcoming you to the Exemplary Buildings Balanced Ventilation with Energy Recovery training. As you've already seen, we are actually recording this session, so if anybody's uncomfortable with that, now's the time to leave. This program is sponsored by the Bullock Foundation and Edwards Mother Earth Foundation, who both provided funding for the Exemplary Building Program, and particularly this technical assistance, technical support component of the program. Myself and David Reddy are presenting today, both from O'Brien 360. David's the brains of the act. I'm just bringing the funny accent. But I also want to thank Lauren Tierney with HDC and Nathan Antonio with HDC as well, and Emma McKay with O'Brien 360, who are kind of the power behind the curtain that are making all of this technology run smoothly. Our learning objectives today are to understand the code meaning of balanced ventilation with heat recovery, energy recovery, to compare and contrast balanced ventilation options, to understand the process steps to designing and installing balanced ventilation systems, understand the components of life cycle cost of those systems, and to raise awareness of the potential pitfalls. This training is not about how to design a balanced ventilation system. You'll find that in the Exemplary Building Guideline document that's about to be published next week, I think, December 6th. This training is about the importance of designing a process that will deliver an effective balanced ventilation system and avoid many of the pitfalls along the way. So we're going to walk you through a series of steps, some context, a review of the kind of fundamental options as far as balanced ventilation is concerned, talk about that process issue. David is going to walk you through the real life experience of some case study projects to see how that's actually played out in reality. And then we're going to spend some time really looking at what we've learned and what we need to do, what our next steps are from this process. So there's going to be some interaction and participation towards the end of the session. Again, this is the appetizer. It's a high-level view of balanced ventilation, focusing on how owners' requirements and project constraints determine system selection and how to avoid pitfalls. Session will also be available as an asynchronous learning module for project teams to watch later on demand. As I've said, it's not primarily a Q&A session, but if you have clarifying questions, please put them in the chat and Emma will call attention to them to make sure that we clarify anything along the way. More substantive questions you can put in the chat as well, but we'll be kind of putting them on the bike rack and holding them for later, and I'll talk about that. The Exemplary Building Program Guideline for Balanced Ventilation with Energy Recovery is about to be released, as I say, hopefully December 6th. It provides more detail of systems characteristics, design and specification details, and the Exemplary Building Program recommendations, which are a set of rules of thumb that are likely to suit many affordable housing projects in this market. Your next step after this training should be to go and read those guidelines. The next step after that is office hours. As part of this session, we're scheduling a couple of office hours sessions, which will be live Zoom Q&A sessions with the presenters. After you read the guidelines, bring your questions that come up from that to the office hours sessions. These sessions will also be recorded and made available along with a written summary of the questions and answers. And finally, also through the generous support of our sponsors, HDC is able to provide some technical support to help answer those general head-scratching questions after the office hours events So if you have a blockage and you need to move forward, reaching out for some technical assistance is something you can do, but obviously not to help you design your project. For that, you need to hire your own consultant. So with that, why do we ventilate? So I think we're all pretty aware now that household air is generally considered to be significantly lower quality than outdoor air. So we use outside fresh air to dilute indoor contaminants. And generally, we're also using it to manage relative humidity. The current standard of practice here in affordable housing has been exhaust-only ventilation with trickle vents and other sources of outside air. And we've had a fairly general process to implementing those systems. So the first step I want to take with you this afternoon is just to do a little timeline therapy. We're going to actually be using Mural, which is a whiteboard tool on the internet. And Emma, I think, is placing a link in the chat right now, which will take you to a whiteboard where we're just going to quickly investigate these two questions. When have you traditionally decided on your ventilation system design in past projects, and who was involved in that decision process? So if you click on the link in the chat, it'll take you to a Mural whiteboard in your browser, and it'll actually take you to this one. And I can see people are already in there, which is great. I'm actually going to hide individual cursors for now, just because it gets a little confusing seeing everybody move around. So the goal here is to drag a color post-it note based on your discipline and drop it in the slot that seems most appropriate, and then double click into it and just write in who would typically be involved in that decision. We're just going to take a couple of minutes to do this. Looks like we have 19 people in the whiteboard, which is great. And we have about 25 people on the meeting now. So a few people maybe not made it in there yet. People seem to be getting the general idea. Okay. Great, good. Generally, people are getting the pattern here. This whiteboard's going to stay open. We'll be using a couple of other boards during the course of the training today. So you can keep this open on your browser. I am going to switch us back to the deck, but feel free to keep working here if you want to. And we'll move on if I can find the right deck. Okay, great. So one thing to be clear just about the Exemplary Building Program in general is that it's a response to climate change, focusing on both greenhouse gas emission reduction, but also on equity and resilience, because those are critical components of an effective response to climate change. Balanced ventilation with energy recovery is about better building performance, but it's one strategy that is at least as much about social equity as it is about greenhouse gas emissions. One of the most tangible symptoms of climate change here in the Pacific Northwest in recent years has been the increased frequency with which Seattle is inundated by wildfire smoke. Wildfire smoke events disproportionately affect the marginalized, who are less able to avoid it and more vulnerable to its health effects. Balanced ventilation provides the capability to offer some level of protection from respiratory impacts. Mechanically supplied ventilation air can be filtered before it's introduced into the living space. Some balanced ventilation systems can also be designed to improve nighttime flushing or to provide mechanical cooling for centralized systems, which may actually help to contribute to improved thermal comfort during high temperature events, which are another aspect of climate change that we've seen. So it's a really tangible and central part of our approach to climate change response. So why are we here having this conversation? Because the 2018 Washington Mechanical Code told us we had to. Requires that all the balanced ventilation must be provided to all R2 occupancies. We're focusing primarily here on the commercial code, which means that in addition to balanced ventilation, you must also provide energy recovery. Now, because balanced ventilation provides more effective ventilation, airflow requirements have been reduced compared to 2015 flow rates. That means less heating load and smaller systems than if we were still using those 2015 rates. However, if you don't have a properly balanced and distributed system, you may actually incur some flow penalties, which might actually increase the flow rates to be higher than 2015 in small units and at least similar to 2015 in larger units. Fundamentally, the Washington State Mechanical Code and the Seattle Mechanical Code are pretty similar, but there are some differences in requirements, and it's important to refer to your friendly HVAC engineer for guidance and details on the specifics of the codes. So what is balanced ventilation? The code definition of balanced ventilation is concurrently operating exhaust and supply fans, delivering flows that are within plus or minus 10% of 5 CFM, whichever is the larger. So the key is you must have both supply and exhaust fans that must both run at the same time. They may run continuously or intermittently, but if they run intermittently, you must increase the flow to provide sufficient air volume over a 24-hour cycle. Continuous operation is recommended as it was before in the old exhaust model. Now, if flows are not within 10% of 5 CFM, the system is considered not balanced, and the flow targets are then increased by 25% to help ensure effective ventilation. There's another component to the definitions, the difference between distributed and not distributed systems. So in both these systems, supply air is provided to all the living and sleeping spaces. There are some exceptions to that for the urban one type format, but in general, we're providing direct ducted outside air to all spaces. On the exhaust side, a distributed system exhausts from both the kitchen and the bathroom. In a not distributed system, the system is only exhausting from the bathroom and not from the kitchen. This is a fundamental difference. And the intent is that a distributed system is giving better air distribution and better removal of contaminants than a system that only exhausts from the bathroom. But obviously there are some complexities that come with that approach. The key considerations here are that a not distributed system has a 25% flow rate penalty, which is added to the target flow rate. And if you also have a system which is both not distributed and not balanced, then it's another 25%. So you're looking at a 50% increase in flow for a not distributed, not balanced system. Considerations for a distributed system are that with an exhaust from the kitchen, the exhaust grill is going to require a filter to keep grease out of the ducts and out of the air handling unit. That filter is going to need periodic cleaning and replacement. If you have a distributed system, there is the opportunity to think about a recirculating range hood instead of an exhausting ranged hood, which would mean one less exhaust flow from the unit, one less duct termination in the facade. But this is generally only recommended in situations where cooking activity is expected to be low. So balanced ventilation is a better solution. The good news is that with outside air ducted direct to all occupied spaces, you're getting better delivery of fresh outside air. It's not being pulled through the building enclosure, which may have moisture concerns, among other things, and it's not being pulled through party walls, which may also carry contaminants from adjacent apartments. And that's obviously been an increasing concern over the last couple of years with the pandemic. Having mechanical supply also means that it's possible to filter the outside air so we can deal with exterior contaminants, either based on the location of the building, if it's adjacent to a freeway or a source of other particulates, or in the case of wildfire smoke, it gives us the opportunity to filter that air. The other good news is that with the energy recovery, we're reducing the energy penalty of ventilation by around 40%. So if it's so much better, why has it not been standard practice? Well, because being better comes with a cost. Balanced ventilation systems are more complex to design, install, commission, and maintain. They require more ductwork, more penetrations, more mechanical space, more equipment generally. There's been too many constraints, and the market just hasn't responded because the cost appeared to outweigh the benefits. But the reality is, now we got to do it. The regulatory hammer is down. Requiring it by code has changed the dynamics in the market, but it hasn't necessarily changed the resource constraints, at least in the short term. But with careful planning, the challenges can be simplified and the costs can be moderated. Elegant, cost-effective solutions generally involve integration and interdependence, requiring a fully integrative delivery process. We'll be talking more about that later. For now, let's learn a little about the various balanced ventilation options. Once again, this is a light touch. We're just looking at the systems in a very simplistic perspective, but you'll be able to look into the guidelines in more details. By the time you're done figuring out how to fit balanced ventilation into your building, beside, behind, above, or below everything else, you'll feel like you've been in a game of Twister. There are basically 4 different approaches to balanced ventilation with energy recovery, defined by how many ERVs you use, where they're located, and how many units they each serve. They fit into 2 groups. You can choose one, or you can try a hybrid if it makes sense for your building. The first type is the unitized type. So that's a ERV in every unit. And then there are the centralized types, either a whole building or a wing, a vertically separated centralized approach, or a horizontally separated approach. The first approach is the unitized approach. This is really the straight line development from the traditional exhaust fan with trickle vents approach. We trade the exhaust fan for an ERV and the trickle vents for supply ducts. Each unit has its own ERV, typically located in a drop soffit above the entry or in a bath above the bathroom. There's no roof penetrations, no shafts, no complex coordination of ductwork in the corridor ceilings, and the ERV is on the unit electric meter, not the house meter. But every ERV has its own filters on both supply and exhaust, which will need to be cleaned or replaced periodically, generally every 6 months or so. From a process perspective, this is a straight line evolution. It's the closest to the status quo, requiring the least change of practice, which may make it an attractive option and maybe the only viable option for some projects. The market is increasingly responding with smaller, more affordable equipment, mostly of the energy recovery type rather than heat recovery ventilators. The biggest issues with this approach are multiple facade penetrations and separation challenges that need careful coordination, lots of duct and soffitting in the units. You're putting an ERV in each unit, and so that's a source of noise, so there may be acoustic considerations, and we have the access and filter maintenance challenge that we've already talked about. So to the centralized systems, there are basically the 3 approaches. The first is to supply the whole building, or maybe a whole wing of a building with a single rooftop unit. This uses a large unit on the rooftop with horizontal distribution, generally in the roof space or below the roof space, If you're putting it inside the building, it may actually require approval by your local jurisdiction. Again, that's something to work on with your design engineers. But it is going to require additional height to accommodate the large ducts that are going to distribute that air across the building. The supply rises vertically between stacks, hopefully, so that you're serving 2 stacks with 1 set of risers. And that then potentially provides for a limited amount of ductwork within the units, depending on how those risers serve the units. The main issue here is that you have to deal with this additional height in the roof. Another significant issue is if you're dealing with more than 4 stories, there are going to be additional requirements, fire and smoke control requirements, including shafts, wrapping of ducts, and so on. Because you are connecting the ventilation systems of multiple units, it's important to have equipment that has good resistance to what we call cross leakage, the transfer of air from the exhaust side to the supply side, which is generally very low, but where you have airflow from multiple units here, that's a greater concern than with the unitized system. And then the other thing is that these are very complex duct designs, and so they need to be designed properly and carefully, and they need to be balanced effectively. The next approach is the vertical separation, stack by stack approach. So instead of having the horizontal distribution in the top of the building, we just put a separate ERV at the top of each stack and only deal with the vertical distribution. So that simplifies the system quite a bit, but it puts more equipment on the roof. And that means a little more coordination. If you've also got amenities, you've got a big PV array on the roof and so on. Most of the challenges otherwise are fairly similar to the whole building approach with this one. The main issue being the additional equipment on the roof, the penetrations in the roof, the curbs, and so on that are going to be required. And then the third option is the horizontal floor-by-floor approach. And this is a sort of significant change. It uses indoor equipment instead of outdoor equipment. It's located in a mechanical space, located somewhere centrally, either on every floor or potentially shared between 2 floors, depending on how many units you have on a floor, what the capacity of the equipment is, and so on. The good news with it is that you've got far fewer penetrations in the facade, far fewer penetrations in the roof, and no vertical shafts to deal with in buildings of more than 4 floors. So the disadvantages are that you're giving up some interior real estate. You've got to have a mechanical closet on every floor or 1 per 2 floors. And you've got a significant challenge with corridor ceiling coordination. There could be a lot of horizontal distribution going on in these corridor ceilings, your domestic hot water. If you're looking at a VRF system, there could be a lot of refrigerant lines. So it's a pretty complex design challenge and a pretty complex coordination and sequencing challenge in construction. Of course, so that's the distribution side of the conversation, and that's where we've focused so far, because it's so fundamentally integrated into the building design. But the distribution decision leads to several more decisions. Perhaps the most important of which is equipment specifications. Which ERV are you going to choose? The right distribution choice can be turned out badly if you hook the wrong pieces of equipment to it. Equipment requirements vary by distribution system type and by overall performance goals. Your energy performance targets, there are various ways you can achieve benefits and savings from higher efficiency systems, but they come with complexity and potentially a higher price tag. And also air quality performance targets. Those are often a trade-off with energy performance and or with cost. The important thing in terms of recommendations here are that the equipment requirements must be translated into performance specifications as part of the basis of design. By setting thorough performance specs for the equipment, you're empowering the subcontractors to propose the specified equipment or an alternative that's not going to compromise the overall performance of the system rather than proposing an alternative that they see as equal but isn't necessarily so. And the other thing to remember is that manufacturer specifications may or may not be reliable. So looking for certifications and ratings by AHRI, HVI, and others may give some additional confidence in performance, but they do tend to limit options somewhat, and they can also be open to misunderstanding. So something to look out for. As we've already mentioned, ERVs offer the potential for cleaner, healthier indoor air via high efficiency filtration. But those high efficiency filters need regular cleaning or replacement. If you opt for a distributed ventilation system, that's going to include a grease filter in the kitchen exhaust. So you have to start thinking about how we plan for operations and maintenance, because there are going to be more steps, more maintenance load involved. Can you expect the resident to do any of that maintenance? Are you going to need to get access to every unit if you've got a unitized system? Or can you locate the equipment so it's accessible for the corridor? If the filters are cleanable rather than replaceable, how will you plan the switch out? If it's an owner priority to offer enhanced protection during wildfire events by installing higher efficiency filters, how's that going to be implemented? Where are you going to store those MERV 16 filters? How often do they need to be replaced? Then, of course, there's regular equipment maintenance. How do you plan for that? Who does it? Whose responsibility is it? Is it an in-house service or a maintenance contract? And then, of course, what happens when it comes time to replace the equipment, either due to failure or at its service life? Is it going to require a crane to get it up onto the roof? Or is it something that can be fit inside an elevator? How long are residents going to be without ventilation while you do that switch out? What time of year should you plan to do that? So a whole set of cascading questions that come out of that. And then there is finally a series of things that are worth mentioning, but not in a lot of detail at this point, that I think of as mechanical symbioses. They're related system interactions that warrant some consideration in your decision making. If you're used to having a boosted flow for bathroom exhaust to get rid of moisture, is the low continuous flow of an ERV going to meet that flow requirement? Or do you need to either think of a boosting system or some higher levels of flow in order to satisfy your moisture control requirements? Do we look at that recirculating kitchen exhaust, because there's some savings potential there? In unit laundry, do you think about a ductless dryer, heat pump dryer in the unit, because that is another elimination of another duct and another penetration? There's some interaction with domestic hot water distribution if you're using mirrored layouts for the units to simplify a vertical riser situation that might actually also benefit your domestic hot water distribution layout. And then, of course, because you're providing energy recovery, that's going to impact the heating and cooling sizing, and there may be some savings opportunities there. As I mentioned, there may at least be an opportunity to provide some cooling into the system if you're using a centralized system. And that's a consideration that should be weighed against other approaches to delivering cooling in a building. So the components of life cycle cost, we've kind of touched on a lot of them already, but obviously first cost considerations can be offset to some extent with incentives and grants. There's the maintenance cost considerations that we've already talked about, and the replacement costs. So it's a fairly complex picture when it comes to putting together a life cycle cost analysis. And so definitely a lot of things to be considering here, and a process in place and a plan in place to manage this is going to be pretty critical. We've talked a little bit about requirements, and one of the things I'd like to do here is just poll the housing providers and developers in the room with a question about design standards and owners' project requirements. That's obviously a vessel in which we can start establishing some of the standards that are so key when it comes to figuring out the right approach to your balanced ventilation solution. So Emma has put another link in the chat, which will take you to a polling question in Mural. And I can pop over to that one. You'll see here, we have a question about design standards or owner's project requirements. And I'm just looking for a quick input from the housing providers, housing developers, about whether you have these kind of documents. Do you have a design standards document? Do you have an OPR or a template for an OPR that you can update for each project as you develop it? If you don't have either, just drop a dot in the neither. And if you have some other way of capturing and communicating your owner's requirements, go ahead and drop that in the other category. Okay. Great. Well, that seems to be most of the activity there, and it does seem like we have a handful of people who have design standards or who have an OPR. See, we've got some people that are like the green dots. Oh, some people are already answering the second question, which I was going to come to later, but that's great. Looks like we've got a fairly clear consensus on that one. Great. Let's jump back here. So, as we've discussed, a lot of decisions. The first decision's been taken out of your hands by the code, but the choice of system for your next project is going to be driven by these organizational requirements and external constraints. Some of them are negotiable and some of them are not, and that's going to vary from one project to the next. So the sooner you decide your organizational requirements, the easier it'll be to guide the project delivery process to avoid costly design solutions and irreversible pitfalls. That's why your design standards, your owner's project requirements become really important. Then you have to figure out what's feasible to meet those requirements and the project constraints, which are project specific. The only way to do that and then estimate the life cycle cost of the different solutions that are on the table is to have all the key players at the table at the right time and involved in the discovery and decision-making process. Who would guess that the biggest cost savings opportunity for a balanced ventilation system might actually come from a conversation with the structural engineer? So, all this talk of owner's project requirements, large group design meetings, life cycle cost analysis, it's making me think of integrative process, which will come as no surprise to those who know me. Many of you are probably familiar with this chart already. It's been around quite a bit. It's embedded in the early integrative design guidelines guidance document that HDC has produced. But for those who are not, I just want to call out the details here. This chart, we have the horizontal axis represents the passage of time with the project delivery milestones marked out on it. The vertical axis represents multiple metrics: cost, level of effort, potential for positive impact, but all increasing as they rise from the origin. The blue line represents our declining ability to impact costs and capabilities or outcomes as the project design and delivery process proceeds. The red line represents the increasing cost of making design changes as the project progresses. So the black line represents our typical traditional design process, where the level of effort is maximized during the CD process. And the brown line represents what we're thinking of as our preferred process, a more integrative approach, where the level of effort happens earlier when the opportunity to impact things is greater and the cost of doing so is smaller. In this version of the chart, this yellow bar is intended to indicate where most affordable housing projects get funding. And so it's a critical point, and why commonly the level of effort occurs to the right of that line, because that's when the funding is available to pay for it. The green bar represents the point where we really need to start the work, because doing it this early is what's most important. Who the key players are and when they should be engaged is really the key to this conversation. As I've said, in terms of your design standards and owner's project requirements, the early work should be done really ahead of anything that's specific to a project. But then it's really important that we actually get engaged early in the process so that we can begin to understand the specific standards, the targets that are being established for the specific project. And that's going to begin with the development team, the architect, but it's going to expand to the mechanical engineer, to key consultants, energy consultants, sustainability consultants, building envelope consultant may be involved at that point. And obviously the general contractor and even the mechanical subcontractor actually coming in this early stage is potentially going to be really important. So it's key to initiate this exploratory early so that the necessary combinations for your selected balanced ventilation plan are ironed out in the entitlement phase, so that cost-saving variances and code alternatives can be pursued and resolved before detailed design documents are developed. So that's the kind of key to the process conversation here. And for some of you will already be aware of it, but I think the primary goal here is understanding how much and how early you can really drill into the decisions. I'm going to hand things over now to David to look at case study examples, and I've got to figure out how to hand off the share. There we go.
Great. Thank you, Alistair.
Yeah.
Let me get this going on my end here. Bear with me. What happens? Okay. Looking good, Alistair, on your end?
Yep, looks good here.
Okay, great. Well, thank you, Alistair, for that great overview of the context and options that we're going to talk about. And, I'm privileged to share with you all the case studies that we're going to talk about to illustrate in the context of real projects the options we have outlined here and in the guidelines. We're going to present them in the order that Alistair described them. So from starting with unitized and then moving into the central systems. And the four case studies are some you may recognize, and some are built, and some are still being built or in design. Sawara is the first one by SHA, Hobson Place South, being built by DSC, and Estelle, also another DSC, and Solus by Solterra. We're going to try and hit on the different approaches, decision drivers, and outcomes as much as we can here. So, as I mentioned, Sawara is being developed by the Seattle Housing Authority. It is, if you're familiar with the Exemplary Buildings program, you may know that we have a handful of what we call demonstration projects. They are a subset of early adopters of these principles, including balanced ventilation with heat recovery. And they were given extra incentives from Seattle City Light and support through this program. And we're gonna, this and Hobson are the other one, but the one thing to the project team here led by Inka Moisen, including Ecotope as the mechanical engineer, and Mark Pack is currently slated to build this project, hopefully starting soon. So this is being an SHA project. It has primarily more what I would say family size units, anywhere from 1 to 4 bedrooms. It is utilizing the unitized approach. When this project was in design, it was shared by the owner that they weren't that interested in considering a centralized approach. They had used centralized previously on one project that included HEPA filtration, serving a stack of units, and it ended up being quite costly and challenging. Fire smoke dampers at every unit, and, just came away where alternatively they had in that same project a number of the units that had unitized ERVs, and they were quite happy with the outcome in those. So when Suara started design, it was made pretty clear early on to just assume unitized distribution, which is one of the things that I think was one of the lessons learned, is that having this discussion on which approach is really important as early as possible, and gather the thoughts of the design team and the owner to try and make that decision, and hopefully dispel any concerns or anecdotal evidence that might be driving decisions. In this case, one of the concerns was odor and sound transmission, and what was shared from other project teams' experience after they had already made the decision to unitize is that there really isn't an odor and sound transmission concern with the centralized approach if they're designed properly. So the key is the decision was made early, which, as Alistair pointed out, you're going to consider multiple options, or do that and make a decision and move forward with optimizing the design. Here's a floor plan diagram of the implementation, highlighting the duct routing from the outside air and exhaust in red, and then the blue is the ventilation air coming into the unit and then distributed to each of the bedrooms. A couple of things to kind of note is that each ERV is located in the ceiling of the hallway. In some cases, it's located in the ceiling of the bathroom, or generally it's in the hallway. There are no fire smoke dampers. All of the ductwork is contained within the dwelling unit. There are penetrations at the exterior walls, both an exhaust here co-located with the range exhaust, and an intake for the outdoor air. Distribution is to every bedroom and also the living area. So that illustrates one of the fundamental concepts of balanced ventilation is that it is providing distributed air throughout, but in this case, not exhausting the kitchen area. So this is not a distributed system under the 2018 Energy Code. This was permitted under the 2015 code, so that wasn't really a consideration, but this would not be a distributed system. One thing that I also wanted to highlight is that when you're, one of the challenges you'll find when locating all these ducts within the dwelling unit is that, softening is dropping ceilings is our recommended first approach to because that avoids penetrating the rated membranes of the floor assembly. But where you do have to, this is an example of what was done in this project, was to wrap the ducts in fire rated blanket, and then have anywhere it does penetrate, those penetrations are sealed. And this is something, this project not having been built yet, it'll be quite interesting to see how this plays out in construction. What the added lessons learned are from that approach. But it does, allow ducts to be positioned out and the diffusers positioned out in the middle of the rooms by doing so, which is a big advantage for distribution of the ventilation air. So this is, the other thing to note here is that the larger units do have in-unit laundry. This shows a ducted dryer to the exterior, which I don't believe that the T-pump or ventless dryers were considered for this project, just based on the timing and the availability of good equipment. But that's one aspect is that to consider is to eliminate that additional duct, as Alistair had mentioned, by using a ventless dryer. That's the exemplary building recommendation. And again, ducting the exhaust to the exterior for the range hood, especially in these units where it's anticipated that a lot of cooking will be occurring. Moving on now to the next case study is the centralized by building wing approach that was implemented by DSC and their team for the Hobson Place South development. The namesake of Bill Hobson, DSC's leader for a long time. And this building was designed by Runberg Architecture, and the mechanical system was designed by Rushing, and Walsh Construction is building it. And it's actually wrapping up construction, I believe, by the end of this year. So this is the first exemplary building demo project to be built, and a lot of information and lessons learned and hopefully data soon as well on performance will be coming. So we're all anticipating this. This is the distribution diagram that Alistair showed, kind of just describing the concept. One thing to note is DSC has at least longer than most developers, experience with already doing balanced ventilation with heat recovery. They built 2 buildings previously with the ERVs and had all their new buildings are using balanced ventilation even before code was required. For Hobson Place South, the team pursued relatively late in the design process, more like late SDDD, extra funding from the Housing Trust Fund called the UHE grant program, the Ultra High Energy Efficiency grant program, which came with a commitment to a FIAS Plus 2018 or Passive House certification. So once that was awarded, the team, which had already designed Hobson Place North using their more traditional ERV strategy, which was centralized by wing, but having all of the distribution ductwork, the main trunks above the roof deck. That presented a challenge for the Passive House project in that it was an opportunity for a lot of air leakage through the ductwork, a lot of thermal losses as well, and penetrations through the building envelope. So the team took a step back and looked at different ways of bringing all that ductwork within the condition envelope. And that is a principle that we're recommending in the exemplary building program, because it does, eliminate, it's more efficient in terms of air leakage and thermal losses, but the ductwork will not be subject to the sun and elements to make it deteriorate with time. It simplifies roof replacement in the long term, and so this is a good example of achieving that goal of bringing all the ductwork within. As Alistair mentioned, the height of the building did need to increase to incorporate these large trunk ducts, and I'm going to show you a floor plan view again. Above the corridor, and this is just one of 3 systems in the building, in this case, serving stacks of 6 units per floor, 4 floors, so 24 units total by this one ERV. It is located on the roof, and these large trunk ducts are above the top floor corridor ceiling. It is here's a 3D diagram of what that looks like. You can see this is one architect I've worked with dubbed this the octopus design, with all these tentacles, emanating out from the ERV, and truly it looks quite muddled and complicated. But once these are all 4-inch ducts, and once they're laid out with the idea of dropping off these main trunk ducts, and provided there's sufficient space, it was well, I wouldn't say easy, but it laid out nicely in the end. Here's some nice pictures of how that worked out. One thing you can see is the extra height in the corridor. The ductwork did need to be located above a rated assembly in the corridor. And also there was a requirement to have a code alternate approved by the city of Seattle to locate this ductwork, or allow this ductwork to be interpreted to be quote unquote outside the condition envelope by the city of Seattle, or basically just accepting this design, which does not meet the clear letter of the exception in the building code for fire smoke dampers on this design. So this is, if adopting this design of putting all this ductwork within the condition envelope as was done here, it's really important to assume, working with your local authority, to have that approved. Nice thing is a very solid case was built to do this. The reasons why are strong, and the considerations made of the ceiling assembly and standby power on the ERV control was all kind of taken and received well by City of Seattle. So and there are a number of other projects in design right now that are pursuing this approach as well. The one other thing, this is an aerial view, which is, I think, really powerful in that it shows DSC's 2 side-by-side projects, north on the right, south on the left. The north demonstrating the approach of having ERVs distributed on the roof, but then all of that ductwork to get to the dwelling units above the roof deck, and just how much there ends up being. Compared to the south face, which in the end is just 3 rooftop ERVs situated over the corridor in each case. And in this project, the ERVs also ventilate the corridors as well, which is a way to reduce, in the north phase, there's a separate corridor air handler to ventilate the corridor. So it consolidates the number of pieces of equipment in that way. That is our recommendation to do so, because it also allows you to capture what are called, to comply with the energy code, the C406 section of the energy code, by providing balanced ventilation with heat recovery for the corridors as well. That's not required by code for 2018, but it's an option, and you can get credits towards compliance by doing so. So if you're already putting these centralized ERVs in your project, I would strongly recommend considering doing so, ventilating your corridors with them as well. It's energy efficient, you get compliance credit, reduce the number of pieces of equipment. The other thing is the south phase really demonstrates, how bringing that ductwork within the building frees up a lot of area for the roof, on the roof, for solar or rooftop amenities or other equipment, as being a benefit as well. So this is, as I mentioned, going to be completed most of construction by the end of the year, I believe, or in January. And the NEA is actually monitoring the ERVs of both the north, NEA being the Northwest Energy Efficiency Alliance, of the north phase and the south phase to compare the performance of the two. So that should be interesting information that we get from this project. The third case study is another DSC built project completed in 2017. The architect was SMR Architects, and this was a design build project with United Systems Mechanical being the engineer contractor, and then Boss Construction being the general contractor as well. This is a nice illustration of what we consider a centralized vertical, again, vertical ductwork serving each individual unit below. But instead of having one larger ERV on the roof with a central trunk duct above the corridor, it's just orienting your ERVs above these vertical stacks. This was the first project DSC built with balanced ventilation with heat recovery and also electric heat for that matter. Their previous design was whole house exhaust with central hydronic heating. And this was seen as a way to both save energy, which both measured and modeled, it was going to save a lot of site energy. And it did. It's about 30% less energy than their previous project built 2 years earlier. And the energy cost savings, because of the cost of gas versus electricity, the cost savings to operate are about 15% less compared, not as much as the energy savings, but still, and ever since Estelle, DSC has continued to utilize balanced ventilation and electric heat in their buildings, and then, you know, moving into the new code, they were well prepared with a lot of experience here. The floor plan diagram here illustrates the vertical distribution. So similar to Hobson, there's these chases, or in this case, rated shafts that were used for the ducts emanating from the roof. And in this case, also subducted exhaust from the bathroom. And that comes up to the roof where the ERV is located over each stack with a plenum manifold distributing up the air to each individual duct drop. One thing, I'm gonna go back actually up to show one distinguishing feature between Hobson South and Estelle, and actually other one consideration is Hobson South did utilize balanced ventilation and a distributed approach. You can see here an exhaust from the kitchen area. This is the range hood here, and the bathroom. So that meets the criteria for a distributed system. And this was driven in part by the passive house goal, very, very tight building envelope. You can see it eliminates any exhaust ductwork from the range. There's a recirculating range hood for this building design. And it was done in part for passive house, but also recognizing that tenants for their buildings weren't necessarily cooking a lot. And so the benefit of a fully ducted exhaust range hood wasn't, it was felt that the balance between providing continuous local kitchen exhaust with the ERV and the recirculating hood was the better solution for this passive house project. So that's one fundamental difference that you can see between these two approaches. This doesn't show this does show the vented exhaust range hood here separately. So moving into our last case study, to illustrate the centralized horizontal floor-by-floor approach is the Solis apartment building in Capitol Hill, built by Solterra. Architect was Weber Thompson, and the mechanical engineer and contractor was Emerald Air, with Cascade Built being the contractor. This different than the other three case studies. This was a market rate apartment project. It was certified under an earlier version than Hobson of Passive House, or PS Plus 2015. So this, again, was an early adopter of balanced ventilation, in part to meet that Passive House requirement. It uses a variation. Our diagram illustrates air for the ERVs, being distributed on a floor-by-floor basis. But in this case, the diagram shows it being pulled in through the exterior wall of the building on each floor. Solis actually employed a variation, which is showing the ductwork distributed on each floor, but the air for each ERV coming down from the roof, and then situating an ERV in a closet on each floor. And this was intended, a very tight development, very challenging, and to run ductwork out to the exterior wall. And this is a way to consolidate it to one shaft of air coming down. You can see fire smoke dampers at each floor for each ERV, but otherwise there are no fire smoke dampers for the penetrations of the corridor assemblies. Again, the building code has an exception for that if you meet certain requirements with your ductwork. This is also an illustration of a distributed system where it's exhausting both the kitchen area and the bathroom and supplying air to the living spaces. This building did include higher floor-to-floor building height than most of the affordable projects I'm at least involved in. And so that did allow accommodating ductwork in the corridor above the ceiling more easily, or at least have more space for it. And that is I would say the biggest challenge, is that coordinating that ductwork. Does not require space within the dwelling unit for vertical distribution, but it does take that valuable floor-to-floor space in the corridor. And the other variations that you might see and consider is as the diagram showed, pulling in air through the exterior is one way, or another project I've worked with had the ERVs itself on the roof and ducting down vertically to each floor and doing this horizontal distribution. So there's quite a few variations of this, and it's these guidelines and the work we're doing here is definitely not intended to kind of lock you in or what we want to encourage is that you do consider variations on these concepts, but with the fundamental idea of trying to avoid fire smoke dampers and optimize the ductwork placement to within the condition envelope and with low distribution losses. So this is a really cool example of that. And all these case studies highlighted is that coming up with setting goals and targets from the very beginning. I would say all of these projects benefited from doing that, and I think Hobson Place South was probably had the biggest challenge in it. It had already been trying to replicate what was done on the north phase, and then had to kind of go back to reconsider that approach once it became a passive house goal. So I think that it continually becomes a theme for all of these, is that setting that goal early, it was extremely important. Having all the right people at the table, being, the contractor was involved in pre-construction on most all of these, I believe all of them actually, and having that dialogue of where can these ducts fit, how big do they need to be, how much room do we need, those are all coordination that needed to occur in order for these projects to be successful. And then keeping everybody in the loop throughout, what maybe seemed reasonable and at the end of SD, once further work is done in early DD, to make sure everybody who is part of that early discussion is continued on to the refinement. And then getting buy-in from your building code official if you do need code alternates, early to recognize those and engage, and like I would say not shy away from it. I think Hobson Place really illustrated a great approach of working with the authority to get buy-in, have a very clear description of the challenges and the solution and the benefits and considerations of that. All of these pitfalls can be avoided with again early team planning and work, coordinated integrative work to design using the principles that I hope we kind of set forth in these guidelines and presentation. One kind of real life lesson learned, actually this came up in a very recent project that to illustrate this pitfall was the schematic design narrative included a corridor floor by floor approach, and the team moved on into DD and brought the contractor in, and the contractor highlighted pretty quickly, this is going to be a problem. The duct getting into the unit from the corridor is going to make it, the corridor ceiling has to come down, and that really wasn't too realistic given it was already at and this diagram shows 7.8, but I think it was 7.6, and just with other clearance issues, going lower wasn't realistic. So this is just the kinds of things that hopefully with the entire team at the table early on, drawing, sketching, thinking about how it's going to be integrated, a solution to this could be developed earlier. Another thing that came up on the same project was a beam down the crossing the corridor that these trunk ducts could not penetrate. So those considerations are just a good example of the coordination the entire team can work on early on. And with that, I'm going to hand it back to you, Alistair.
Great. Awesome. Thanks, David. I will share my screen. So, great run through, great examples. Several of you have already answered this question, but clearly I think David's case studies there sort of illustrate that this is not business as usual. If we jump back to the poll, we're going to get the right one. What's the next exercise? I'm going to get to this tab. I want to get to this tab. There we go. So if anybody hasn't already answered this question, seems like we've got a fairly good sense here that the way we've done it is not going to meet the new requirement. Now, obviously, if you're thinking the way we've done it is exhaust only, and now we've got to do balance, then that's an easy answer. But I think obviously we're talking about a bigger set of requirements here. And interested to see who the countercultural person is here who's switched their dots between the two questions, but that's great. It's good to see counterculture, because that's what we need, right? In this situation, we're trying to figure out better ways to do things. Okay, so let's move on. So we're at the end of the first hour plus a little bit, and have kind of covered most of the delivery content. I'm just doing a quick step back to review the learning objectives. We've covered, the code meaning of balanced ventilation, of energy recovery, heat recovery. We've looked at these different distribution solutions, both schematically and some real world examples. Talked at different levels about the process steps and change in the process. It was interesting to note, you're obviously all your good examples in that first timeline process. Everybody really was saying they were making their ventilation decision in SD or DD, which is great, but clearly not with such a kind of holistic approach, maybe kind of pulling in more stakeholders early in that conversation being kind of the key difference from that point of view. Understanding the components of life cycle cost. This one, obviously, we've touched on a very superficial level. The guidelines go into a little more detail here, but there are so many variables and so many unknowns. It's very difficult to drill down on real examples of cost at this point. We're very much in the discovery phase right now, but at least understanding that there are lots of different components to the life cycle cost of ownership, and recognizing that the first cost choice that makes the most sense from your capital budget perspective may not be the best choice from an ongoing perspective in terms of operating costs, maintenance realities. And when it comes time for maintenance and replacement, how are your operating reserves set up to be able to fund that replacement when the time comes. So, and I think David did a good job of illustrating examples of potential pitfalls, and just in general terms, I think we've kind of highlighted much of what's out there to be wary of. So what I would like to do now, and you got a little preview when I couldn't get to the right mural session there. I want to take a little time now just to focus in and think a little bit about what you've learned. Some or a lot of the content maybe is not going to be new to some of you. Hopefully there's some different perspectives that has been new and helpful. What I'd like you to do is go to this third session, which Emma's put a new link in the chat to go to. And there's 5 questions here. It's another post-it note setup. There's post-it notes by discipline on the left-hand side of the sheet. You can drag and drop those into these 5 question areas. I'm actually going to set things up as a private session to begin with. And so that means you'll get a few minutes to look at have your own thoughts, post your own notes, and then we'll open it up publicly. So the first 5 minutes will be time for personal reflection, thinking about these 5 questions and figuring out what it is you want to contribute. I just got to change the session here. How am I going to do that? Still didn't get the right one. Let's try that again. There we go. Okay, so we've already got action going on. I'm going to put you into private mode now. Okay, so I think that's working. Yeah, so take a little time. As I say, we're going to take just about 4 or 5 minutes just to start thinking about these things. What surprised you from this presentation? If there's anything that's new, different that you've heard. What are the things that have come across to you as the most important when planning balanced ventilation in your next project? Which of the distribution approaches are you considering? If you've already got a project in the pipeline, have you started this work already? And do you have a particular approach that you're already kind of leaning towards? And then what are your biggest fears? You know, which of the pitfalls do you feel is the most threatening, the most disturbing, the hardest to manage? What's likely to trip you up? And that might be, you know, because of an organizational concern rather than a technical concern. Might be a capacity issue, might be something specific to your project. You know, any of those things. And then what's your next step based on what you take away from this session today? What's your next step to take you towards a successful outcome, whether it's on a specific project or whether it's a step organizationally that you need to take, or a step personally that you need to take or want to take from an education standpoint. Of course, one of the things in that next step column should be, I'm going to read the guideline as soon as it's published. And then I'm going to come to the office hours. So we'll give you a couple more minutes to figure out your own thoughts on this, your own comments. And we'll open it up and you'll still be able to add to comments. Hopefully seeing other people's will maybe give you some new ideas, give you a different perspective. We'll just give you 2 more minutes in this private setup. Okay, let's go ahead and open up the board. See what we've got going on here. Okay, great. Complexity. More floor-to-floor height, combining HVAC, no slam dunk approach, yeah. And of course, that's probably partly because we're so early in the process. Hopefully over time, we'll start to understand that there are some preferred approaches. But again, because it depends so much on your own organizational requirements and the specifics of each building, each occupancy type.
Yeah, Alistair, one thing that we didn't dive too deeply into, but with one of the, you mentioned that using a centralized approach does kind of open up the opportunity to install a heat pump or in the central unit.
Yeah, great point.
A solution that we're looking at on with a couple different teams and evaluating what is the impact on thermal comfort, particularly on a very hot day that we all experienced last summer. The ventilation system, the amount of air is not that much, so it can't handle too much cooling load, but we believe it does take enough of the edge off, so to speak, on those really, really hot days. So that centralized approach opens up that opportunity, and I think more teams are concerned with that.
Yeah, great point. Thanks, David. Okay. Well, this is good. We're seeing activity slowing down a little bit, but this is great. Interesting stuff. A lot of a range of what people see as the most important: early planning, full consultant team, bringing the GC and relevant subs in earlier, which is something that we've seen tremendous success with. Obviously, it depends on the situation as far as your resources, but bringing not just the sub, but when you have the opportunity to, not just the GC, but when you have the opportunity to bring the sub in, can be really, really helpful. And then some really tangible things, confirming clearances and corridors. And I kid you not, you'll notice down at the bottom, I actually included the structural engineer as a discipline in here, mostly just as a point of irony, because typically I don't think anybody would think about the structural engineer as part of this conversation, but they certainly potentially have a big role, even in the examples David was giving. If you're considering distribution, it seems like there's quite a lot of people talking about centralized here. So yeah, and I think that secondary opportunity of providing some cooling is probably an appealing one compared with looking at cooling in every unit. So yeah,
one thing I'm excited to see is a hybrid approach being considered. Where you have maybe centralized system for what I've seen is that I think centralized is a really nice fit for really when you have a lot of small units, studios and one bedrooms. The amount of ductwork in the dwelling unit can be reduced pretty dramatically.
Yeah.
But then the larger 2 and 3, 4 bedroom units, using maybe a unitized approach for those, because there are larger, the cost to per ERV is the same, whether it's a studio unit or a 1 bedroom, at least for the equipment, not the ductwork.
Yeah.
So I hope teams do consider looking at a hybrid, not just one size fits all.
Yeah, I think that's a great point. Okay. So interesting stuff. Things seem to be settling down a little bit. People have got their ideas out. You're all probably looking at this on your browser. I have it up on the share. The pitfalls. Some good ones. This will overwhelm all the work on cost-efficient design. Yeah. Well, these things all go hand in hand. Now that this is part of the baseline, although the cost-efficient design conversation started before balanced ventilation, came to us. Obviously now it's something unavoidable. So, the good news is that things will clarify. The good solutions will tend to show up more. I think the market will respond with better options, and eventually, hopefully, we'll be able to kind of take these additional costs in stride. But clearly, at the moment, it is a challenge. And the Exemplary Building Program has been trying to find some funding to help demonstration projects to get to goal, but the long-term goal is that we have to figure out how to get this into a budget that works, or have funders recognize that this is a real cost that's been added to delivery of affordable housing.
Yeah, and it's not one thing I want to reinforce is this isn't just Washington. It is most all of the codes, major codes, ASHRAE, IECC are moving towards balanced ventilation with heat recovery as a requirement for these building types.
Yeah,
we're a little ahead of the curve in Washington State, but within 2-3 years, it's going to be pretty universal. So
yeah,
it's recognized, and also the exemplary building demonstration projects included energy studies, and balanced ventilation with heat recovery is the second highest impact measure to implement in terms of energy savings and carbon footprint, be after heat pump water heating. So I think I've certainly been pretty surprised with the impact that we've seen in the modeling, certainly of balanced ventilation with energy recovery, because hadn't necessarily anticipated that in the old days. I'm conscious of time. I realize because we started a few minutes late, we're running right up against 1:30 end time. I was originally planning to do a little prioritization voting exercise here, but actually I think I'm going to skip that. I think there's lots of good stuff up on the board here. We will get this organized and tidied up, and it'll be a PDF follow-up, so you'll all be able to refer to what comes out of this going forward. So I am going to step us back to the PowerPoint. I'm going to skip the prioritizations. In terms of observations, I planned originally we'd have a few minutes for people to share, but actually, as I say, we've let the time slide a little bit, for which I apologize. So I just really want to close out by once again referring you to the Exemplary Building Program guideline documents, not just the balanced ventilation, which will be published next week, but the early integrative design, the enclosure details. There are others all available here on the Exemplary Buildings website, and I think Lauren had pasted the link to that in the chat as well. We will follow up with these office hours. We held off on committing dates for them until we knew when the guidelines were going to be available, but we will be sending out an invitation to those office hours sessions to everybody who was registered. There will also be a SurveyMonkey evaluation coming out, which we would appreciate it if you would respond. If you didn't pre-register for the session, but you just joined it today, if you could drop your email to Lauren at housingconsortium.org so that you can be added to the attendance list, and you'll then get the evaluation and the other follow-up information. And finally, on Thursday, we're doing a session like this, focusing on domestic hot water, focusing both on distribution and equipment, very much the same as balanced ventilation, really, but dealing with hot water rather than fresh air. That's on Thursday, December 2nd, again from 12 to 1:30. And with that, I'll say thank you to you all for attending and for your contributions, and looking forward to the next opportunity to engage, and wishing you all the best with your next project. Thanks very much.
Thanks.
Thanks, everybody.
Thanks, Alistair. Thanks, David.
Thanks all.
Wonderful presentation.
You're welcome.
Look
Bye,
forward to
everybody.
seeing you all in office hours. Yeah,
Yeah, that's right.
I know.
Bye.
Bye, everybody.